Hello and welcome back to the channel. Today we're going to be continuing our DP-600 exam preparation course, and we've made it to video 11 of 12 in this series, and today we're going to be looking at performing exploratory data analytics. Now there's this video and then one more video to go, so we're very close to the end, so keep going, we're almost there. And within this video we're going to be looking at descriptive, diagnostic, predictive and prescriptive analytics. And specifically, we're looking at how to implement those things within Power BI. We'll also be taking a look at the data profiling tool, which is part of the Power Query experience. So you'll see that within the Dataflow Gen 2 and also within the Power Query engine in Power BI as well. Towards the end of the lesson, we'll be finishing with 5 sample questions just to test your knowledge of this section of the study guide. And as ever, I'll be leaving links to further learning resources if you want to go into more detail about anything that I mention in this video. And I'll leave a link to the school community in the description below if you want to grab those learning notes. Okay, so just to kick us off, I think it's worthwhile just going through those 4 types of analytics and looking at what they mean in Microsoft's own words. So we'll start by looking at descriptive analytics. So when we talk about descriptive analytics, we're talking about analytics that interpret past data and KPI to look for trends and patterns. So we're looking at what happened in the past. We're describing what happened in the past when we talk about descriptive analytics. And we'll be going into some examples of descriptive analytics and some visuals you can use to perform descriptive analytics. But for now, let's just look at these definitions. The second one to know is diagnostic analytics. So diagnostic analytics varies from descriptive analytics because we're not just worried about what happened in the past, but we're looking at analytics that describe which data element will influence specific trends and the possibility of future events. So when we talk about diagnostic analytics, we're not just talking about what happened, but we're inferring why something happened. So we don't just care about, okay, what happened in the last 12 months, but we're looking for more detail around particularly why certain events or certain trends might have occurred. Now, typically this uses techniques like correlation analysis and data mining, at least in the words of Microsoft. And there's various techniques that we can use to kind of infuse our visual reports in Power BI's to try and expose some of this diagnostic information. Number 3 is predictive analytics. So with predictive analytics, we're going to be using statistics or machine learning as well to forecast future outcomes with statistical models and machine learning techniques, as I mentioned. Now, these analytics provide context and clarity for future decisions. So in predictive analytics, we're not just worried about what's happened in the past, but we're using that data, our historic data, to think about what might happen in the future with some amount of certainty. And finally, the next level of analytics is prescriptive analytics. So in prescriptive analytics, we're not just predicting what's going to happen in the future, but we're providing recommendations and we're recommending actions that might be the best course of action to either prevent a particular scenario or to increase the chances of a particular scenario, particular outcome for your business. Now, with all of these 4, the clue really is in the name. So if you're struggling to remember what each of these types of analytics is, then it helps just to go back to the first word in each of them and really understand what each of them means. So in the first one, we're describing. So it's descriptive analytics. We're describing what happened in the past. With diagnostic analytics, we're diagnosing. So we're not just describing what happens, but there's some sort of causality there. We're thinking why something happened in the past. So we're diagnosing a particular trend. Obviously, with predictive analytics, we're going to be predicting what happens in the future. And with prescriptive analytics, obviously the key word there is prescribe. We're not just predicting what's going to happen in the future, we're also prescribing a suitable course of action that you should follow to optimize a particular outcome in the future. Now, one thing I'll say before we start here is that most of the content for this section of the exam comes from, or at least is inspired by, the PL300 exam for the Power BI Data Analyst. So that is what we'll focus on for this section of the study guide. For me, it's a bit less about descriptive, diagnostic, predictive, and prescriptive analytics, although you could argue that the visuals that we're talking about here align to one of these 4 categories. Really, it's more about Power BI and the visuals in Power BI, when you should use which visual, and when you should use specific Power BI features So that's what we're going to be focusing on in this lesson. And when it comes to visuals and choosing which ones you should use when, well, visual selection is somewhat subjective, I would argue. For the exam, I recommend that don't try to be too clever when you're thinking about visual selection. So they might ask you, when should you use this particular visual? Or given this scenario, which visual would you choose? So instead of trying to be too clever, instead I would recommend thinking about what Microsoft see as the main use case for a particular visual. Get inside the heads of the examiner and of Microsoft and think about how they want you to use the tools. Keep that in mind as we go through the following examples. Okay, so let's go through some of the commonly used visuals in Power BI and when you might consider choosing them or maybe not choosing them as well. So let's start with the table and the matrix visualization. So these are really good for visualizing fine-grained details in your data, allowing your user, the report user, to explore the data themselves, right? And these are commonly used in drill through functionality. So when you want to provide the user the option to drill through to find more detail about a particular metric, you might allow them to drill through, and we'll be talking through that functionality in more detail a little bit later on. They can also be used to display aggregate information. So for example, the revenue broken down by month, for example. One of the drawbacks of the table and matrix visualizations that obviously it's difficult to spot long-term trends, at least visually. Next, we have the bar and the column chart. So when you have one categoric variable and one numeric variable, for example, you might be looking at the revenue by region. These are particularly useful. They can also be stacked if you want to add in another categoric variable into your analysis. So maybe revenue by region, but then also by product type as well, just to give it an extra layer into your analysis. Again, bar and column charts, they can be used to visualize time series information, but it does get a bit messy if you've got lots and lots of time periods along your x-axis. Generally, it's better to present time series information on a line chart, which brings us nicely into the next one, which is the line and the area chart. As I mentioned, these are really good for visualizing time series information. You can fit a lot of information into one chart over large time ranges. We can also use the legend to kind of break up a single line into multiple lines to compare how that metric is changing within each category over time. Now, another variation of this is the area chart on the right hand side there. My personal opinion is I don't really like the area chart. It's difficult to interpret all these different areas because the color of each area is kind of impacted by the color underneath it. So it can be difficult to interpret, in my opinion, from a user perspective. But again, this is not about my personal opinion. It's about what Microsoft sees as the core use cases for each of these charts. Next, we have the card visualization. Now, these are obviously really good for KPI metrics, and you can also include percentage change metrics. You can add a bit more context about what's happened. Is that sales amount an increase or a decrease since the last sales amount as well? Now, out of the box, by default, it doesn't really give you that longer term trend, but it can be coupled with things like a spark line. So if you want to show the momentum of a particular metric over time, adding that spark line can be really useful to give your users a bit of context about how that's changing over time. And the card visual is something that has been developed quite a lot by Microsoft over the last few months and years, and it's actually quite feature rich now, so you can really add a lot of information into these card visuals. The pie chart, donut chart, and tree maps are a little bit controversial, but their main goal is to show ratios between different categories. Now, the reason why pie charts and donut charts, these kind of ratio charts, can be somewhat controversial is that they're more difficult for the human brain to interpret the difference between an area, which is what we're showing in a pie chart or a tree map, for example, and a more linear comparison that you get with like a bar chart. Another potential downside of this type of visual is that by presenting ratios, it does somewhat obscure the overall numbers. So you might be comparing the sales in USA to the sales in the UK as a ratio, but you don't really by default get a view of the overall sales in each category. Now you can add that to the labeling and also potentially a tooltip to add that information in, but I would argue if you're going to do that, there's better visualizations to choose. Another downside is that we can't really see the trends over time. So similarly with the card visual, we're only getting the point in time metric for that particular metric, right? We're not seeing how that metric has changed over time, which is normally more useful for the user. Next, we come to combo charts. Now, these are typically used to visualize more than one metric on the y-axis. So you can see here we've got the bar chart showing one particular metric, and then we've got a line chart showing another metric on top of the same visual, right? Now this can be useful in some scenarios, but you do have to be careful because sometimes this allows the user to come to a certain conclusion about correlation between these two metrics, which you might not actually be correct, that correlation. And it can also be difficult for a user to interpret which axis is showing which metric. Often you need a really good legend to explain the differences between these two axes, these two metrics as well. Next, we come to the funnel visualization. Now, these are really good for showing some sort of movement through a linear process. An example here would be tracking website conversion. So at the top of your funnel, you might have a website viewer visiting your website. Then the next stage in that linear process might be, okay, they're going to a product page. Then the next stage might be, okay, they've clicked on buy, they've added something to their cart, for example. And then the next stage in the process might be they've actually bought the product, and so on and so on. So when you've got linear processes and you're trying to visualize some sort of movement through that process, funnel visualizations are really useful. Now, if I was to be picky, I think you could argue that it is difficult for some users to grasp the scale of the difference between each of the levels in this funnel. But again, that's probably not something for the exam, that's just personal preference. Next is the gauge chart. Now, the gauge chart is useful when we want to show progress of a particular metric towards a goal. So say you have an annual revenue target and you want to show halfway through the year that, we're actually at 53% of our target, so we're on track, for example. Next up is the waterfall visualization. So the waterfall visualization is useful for showing a running total over either a time period or within specific categories, right? So the goal here is really we want to understand which periods or categories contribute most to that change, to that overall figure, right? And again, from personal experience, the waterfall chart I think should be used carefully because it can be, in my opinion, somewhat difficult for users to interpret, but that's just based on my experience. Next, we have the scatter chart, which are generally used when you want to visualize two numeric or continuous variables. Now, again, you can add more information to the legend of these types of visuals if you want to, add a further layer of analysis. So you might be visualizing someone's age versus their height, and then your third variable that you want to add into that analysis might be the country that they grew up in or the country that they live. That might be an extra variable that you want to add into this analysis, and you can do that by color coding the dots, also changing the shape of those dots as well. Now, obviously, you need to be careful when you do that, adding a third variable, because having a scatter chart with lots and lots of different categories of different colors can be quite difficult to interpret from a user perspective. Another kind of warning with these types of charts is that it can sometimes lead the user to come to conclusions about correlation between these two variables. And as we know, correlation doesn't always equal causation. So that's something to bear in mind. As a report author, you might want to compare these two variables when in reality, they might not actually have a causative relationship. Next, we've got custom visuals. So custom visuals help you go beyond the out-the-box visuals that come with Power BI. And there are lots and lots of custom visuals that you can explore, the app source. Now, these can be really useful if you want to use slightly more niche visual types that maybe haven't made their way into the core Power BI visuals set yet. And of course, bear in mind that if you use a custom visual, these are normally built by third parties, and sometimes they involve licensing and things like paywalls. You might be able to use it for a short period and then you have to pay, but that's something just to bear in mind around custom visuals. Now, the final visual type we're going to look at is the Q&A visual in Power BI, which allows users to ask natural language questions about the data in your underlying data models. Now, this sounds good, but in practice, I think it's difficult to implement well. Obviously, the questions currently need to be carefully articulated to kind of match your data model. So it requires the user to understand the columns and the tables in your data set to craft good questions that can give good results, basically. Currently, it's only available in English and Spanish as well if you enable it in the admin settings. So that's a summary of some commonly used visuals. Now let's look at some Power BI features that can help us as report developers to go kind of an extra layer in our analysis to help with maybe some of the diagnostic elements or the predictive elements that we're looking for in this part of the study guide. Starting off with the drill down functionality. So drill down basically allows your user to explore your data through layers of a hierarchy. And that hierarchy can either be explicit, so as a Power BI hierarchy, or it can be implicit. So maybe you haven't actually defined it as a hierarchy, but there is some implicit hierarchical relationship between these variables. Now, a classic example of a drill down might be to visualize at the top level of your drill down revenue in a particular country. And then you might want to drill down and look at revenue by specific state. And then within that state, you might want to look at revenue by store in a specific state, for example. Now, alongside drill down and drill up functionality, you also have drill through. And drill through is a Power BI feature that allows users to drill through from one report page into another report page, and it carries through that information that they click on. So in an example here, you might want to drill through this SharePoint category and take them through a different page in the analysis, pre-filtered based on whatever you drill through on. Now, obviously with this drill through, you need to think carefully about the user journey in your report and the navigation journey that they're going through. You might want to add in things like back buttons to make sure that they don't get lost in your report. Now, with both of these features, again, this is just from personal experience, it requires your end user to have knowledge of drill down and drill through. So I would argue this is a bit of a downside for these features, but something to bear in mind when you're authoring these reports. Next up, grouping. So grouping allows report authors to group two or more categories within a visual. We can create groups of months in this example, or anything really that makes sense for the particular visual that you're creating. Now, when your data is continuous, so it's numeric, you might want to use binning. And binning basically allows you to create different bins for these continuous variables. Now, an example of this might be to create a salary bin. So rather than just have salary as a number, you might want to create salary ranges. So from 0 to 30K, 30K to 60K, for example. And obviously that opens up different visual types that you might want to explore and use for this type of data. Some other features to be aware of are reference lines. So this allows report authors to provide a static reference line across the X or the Y axis to give the user some more context. So it might be the average sales amount for salespeople. So maybe you're visualizing how all the different salespeople have performed, and you can see all of the data. Well, it might be useful to show report users what the average is so that they can make a comparison, give them some context for that comparison. Another feature here is around visualizing errors. So if your data set contains some sort of errors in them, normally it's around prediction uncertainty or measurement uncertainty, then we can use error bars to show that uncertainty to the user. Now, these can either be markers, or they can be lines, or they can be shaded areas. Maybe if you're doing like a time series forecast, that kind of thing, you can have a shaded area for the uncertainty of a particular prediction. Now, obviously this requires data on errors or prediction uncertainty. Next, we have what if parameters. So we can use what if parameters to perform some, what I would say is kind of rudimentary scenario analysis. So giving your report users the option to change a particular variable, particular parameter. In this case, we've got discount percentage, and they can see what impact that has on a particular metric in the chart below. Now, to actually get what if parameters to work, you need to do quite a lot of data engineering and potentially prediction algorithms as well. So it can be quite difficult to set up a good what if analysis. Finally, we've got time series forecasting, and this can be accessed in that analytics pane. So the third icon when you're setting up a visual is the analytics pane. And here, if you have a time series data set, you've got revenue numbers for the last 24 months. For example, Power BI gives you the functionality to create a time series analysis. Obviously, this is quite limited, and I would argue you should be careful here. If you want to be doing any sort of serious time series analysis, I would argue that it shouldn't be done solely within Power BI, but the functionality is there and you might get asked about it. Great, so let's finish off this lesson with a look at the Power Query data profiling tool. Okay, so let's just explore the data profiling tool, which comes with the Power Query engine. So we can use this in a Dataflow Gen 2, or also in the Power Query engine in Power BI Desktop, if you're using that as well. Now, what I've got here is just a query on this revenue data set, and I want to explore some potential data quality issues in this data set. Now to do this, we can go to the View tab and have a look at the data view, enable column profile, and then we've got a few different options here. So show column quality details. If we just do that one to begin with, and let's just explore what that gives us. So we can see we've got these three kind of categories. So it goes through each column and it gives us a percentage of how many values in that column are valid, how many are errors, and how many are empty. So it gives you a really quick indication of column quality. Now by default, you can see down here that the column profiling is based on the top 1,000 rows. So currently it's looking at the top 1,000 rows, and for this dealer ID column saying that none of them are empty, there's no errors, and 100% are valid. Now if we change this to the entire data set, obviously it's going to take a bit longer to calculate, but then it's going to look at your entire data set, every value in this column, and it's going to perform that same categorization. As you can see, this data set looks pretty good. We've got 100% valid for all columns, no empty and no errors. So that's good. If we go back to the data view, now we click on the column value distribution. Let's have a look at what that gives us. So now we've got this quite high level view on the distribution of values within this column. And if we make that a bit bigger here, we can begin to see how many of these values are distinct. Now, to explain the difference between distinct and unique, I think it helps to look at this column here. So we've got true and false values in every row in this column. Now it's showing as a distinct count of 2, which is obviously referring to true and false. So it's kind of like a distinct count of the values in that column. Unique means values for which there is only one row. So here there's no unique values because there's true in more than one row. You know, these are not unique. It's included in multiple rows. And false, there are actually multiple falses. So if in our sample size here, we only had one false value, then it would be in fact unique. So we'd get that 1 in the unique column, but currently because we have more than one false value in this column, it's not unique. So there's 0 unique values in this column. So next up to explore, we have the details pane. So if we enable the details pane here, and then we click on a specific kind of distribution we've got here, and make this a bit smaller. So we get a bit more information about the distribution in a particular column. So we can see the counts, the error counts, the null counts. We can also see the distinct count, unique count, empty string counts, and the minimum and the maximum values. Now, obviously this is a minimum maximum of a string value, but it would also work with numeric numbers as well. I think this column only has units sold 1. Yeah, so the min and the max is also 1, so it's not a particularly good example here. And we've also got things like the average, standard deviation, number of odds, number of evens, so it gives you a bit more detail about what there is in that column. Now, once you've got a pretty good idea about the kind of distribution of a column, you might be able to spot things like duplicate values in here. What we can do is we can right click on it and we can remove duplicates, or you might want to remove errors as well. You can do that from just right clicking on this top section here, and it gives you a quick way to remove or replace these errors or duplicates as well. Okay, let's just round off this video by going through some practice questions to test the knowledge of what you've learned during this section of the exam of the study guide. Question 1. A company annual report shows a net profit of $34 million. Now the company has 12 business units, each with their own net profit or loss amount. Which of the following visual types could best be used to visually show how each business unit contributed to the overall net profit metric? Is it A, a line chart, B, a scatter chart, C, a matrix chart, D, a waterfall chart, or E, a question and answer visual? Pause the video here, have a think, and I'll reveal the answer to you shortly. So the answer here was the waterfall chart. As you remember when we were going through the waterfall chart, one of the core use cases of that waterfall chart is to break down one top level metric into its constituent parts to allow the user to explore how each, in this case, business unit contributes to the overall net profit metric. Now, the other visuals that we've listed here, you might be able to glean some of that information, but as I mentioned previously, what we're after here is what would be the best visual to visualize this information. And for me, that's the waterfall chart. Question 2, you want to add measurement error bars on a time series line chart to show the potential error in each measurement. Where would you go to add this information to your visual? Is it A, the analytics pane, B, the format visual pane, C, view tab and show error bars, D, the build visual pane, or E, in the model view? So the answer here is the analytics pane. When you're configuring the settings for a particular visual, there's obviously 3 panes or 3 different windows that we can use to declare different settings, and the error bars functionality is included in the analytics pane. It's not going to be the build visual pane. That's where you add your different variables, your different columns to a particular visual. Format visual, that's where you change things like the text and the border and all that kind of thing. It's not going to be the model view, because that's where you define relationships and things like that. And it's not going to be in the view tab, show error bars. That doesn't actually exist, that functionality. I just made it up. Question 3. You want to visually compare 2 continuous variables, age and height of survey respondents in one chart. Which of the following visual types could best represent this data? Is it A, a line chart, B, a stacked bar visual, C, a scatter visual, D, question and answer visual, or E, a matrix visual? So the answer here is C, the scatter visual. Obviously, when you're visualizing 2 continuous variables, so age and height, then probably the best visual to use for that would be the scatter chart. Put your height on the y-axis or your age on the axis, and then you can plot different dots for each of your survey respondents. Again, the other visual types not really going to help with that kind of analysis. You could argue that the matrix would potentially show you all of that, but it's going to be a really big chart if you've got lots of respondents. So the answer here is C, the scatter visual. Question 4. By default, the data profiling tool reviews the top n rows of your data set to show you potential data quality issues. So what here is n? So how many rows? Is it A, 10, B, 100, C, 500, D, 1000, or E, 10,000? So the answer here is D, 1000 rows. As you can see here from that visual, by default, the column profiling is based on the top 1000 rows. Obviously, we can change it to include the entire data set as well, but by default, it's 1000 rows. Question 5. Which of the following features of the data profiling tool can help you identify duplicate values in a column that you plan to use as a key to join on? Is it A, column quality details, B, column value distribution, C, column duplicate analysis, D, column key constraints, or E, group by? So the answer here is B, the column value distribution. So as we mentioned, one of the key use cases for the value distribution is to look for duplicate values, because if you've got a key that you plan to join on, you want to be looking for duplicate values in that key, and in a column with no duplicate values is going to look like this, with just a flat line. So every value is going to be distinct here. On the left hand side, this would indicate that there are some duplicate values. There's some values here that have a count of more than the others, right? So this would be a potentially problematic key on which to join on, but this date ID column, all of the values here are unique, at least in the sample of data that you're using for profiling. The column quality details, A, doesn't give us this information. The column duplicate analysis, C, doesn't actually exist. Neither does D, the column key constraints, and E, the group by. Okay, you could potentially use a group by to look for duplicate values, but it's not a feature of the data profiling tool itself. Congratulations, we're nearly there. Only one section of the study guide to go. In the next lesson, we'll be looking at the final section of the study guide. We'll be looking at how to use SQL to analyze data via the Lakehouse SQL endpoint in the data warehouse, and also via the XML endpoint as well. So make sure you click here to join us in the last lesson in this series. I'll see you there.